So we've talked about the unit circle in class and in a previous video. I just want to go over a pattern that you can use for finding angles in this thing. And it's pretty easy to remember. I think it's pretty intuitive that we start at 0 degrees, right? And what I mean by that is this angle here, theta, which sweeps out counterclockwise starting at this line, the positive x-axis. That theta is 0 degrees when you're at the x-axis itself because it hasn't gone anywhere yet. But as you sweep out angles in this unit circle, you can see all those special angles we've been talking about. 30, 45, 60 degrees, 90 degrees is straight up. These all make sense. You might not be as familiar with angles in the other quadrants, but it's going to follow the same pattern. We have 120, 135, 150 degrees, 180 degrees. You see we're going by 30 degrees or sometimes 15 degrees at a time if you're on one of those special perfect diagonals. And then over here, 30 more degrees makes 210. Then we have 225. Then we have 240 and 270 and 300 degrees, 315 degrees, and 330 degrees. I promise you I did not set out with one of my life goals being memorize the unit circle, but when you do it enough, it just sort of clicks. You may also want to memorize the radian measures. Even if you know how to change 30 degrees to radians by multiplying by pi over 180, it is useful to just memorize these things. This is pi over 6 right here. This next guy is pi over 4, and this next guy is pi over 3, right? The next one's pi over 2 at 90 degrees. And you can go ahead and memorize all of the radians if you want. Honestly, I don't. What I do is I say, if I need this one, for example, let's say I want to know point F in radians. What I do is I just say, hey, look, 120 degrees is twice as big as 60. Okay, I'm going to circle two that I'm interested in here. There's 120, there's 60. 120 is twice as big. So that means this has to be 2 pi over 3. And, I don't know, 150, let's pull a different color in here. 150 degrees is 5 times as big as 30. So I guess that means this is 5 pi over 6. Sorry about the obnoxious green there, but you get the idea. So that's one thing you can do to memorize the radians. Another thing you can do, I got to be careful which ones I erase here. Another thing you can do to memorize radians is just notice that they go in a pattern just like other things. So I'm going to get rid of some of these. And now let's try writing radians this way. So I've got my pi over 6 here. And why don't we call this next one 2 pi over 6? Okay, because 60 degrees is just twice 30 degrees. And let's call this one 3 pi over 6. And then 4 pi over 6. And 5 pi over 6 is going to be over here. We skip the perfect diagonals when you're doing this. 6 pi over 6. And you think, why am I doing 6 pi over 6? Well, if you want to keep the pattern going, it's easy to see that way. But of course, it's just pi, right? That's a half circle. And then over here we have 7 pi over 6, 8 pi over 6, and 9 pi over 6, and so on, and so on, and so on, all the way around until we get to 11 pi over 6. I guess if you wanted to go all the way around, you could say 12 pi over 6, but that's just 2 pi. Now, you notice I left out the perfect diagonals because they don't go according to pi's over 6. They go according to pi's over 4. So this next one is going to be 3 pi over 4 at G. And then I have 5 pi over 4 and 7 pi over 4. So if it helps, you can remember the radians in terms of pi over 6 and pi over 4. Or if you wanted to get fancy, just do pi over 12 and have the same denominator all the way around. But that's up to you.